Ladies and gentlemen, Redis geeks and geekettes, welcome to Redis Day.
Hello everyone. Last speaker of the day, so hopefully we'll get done quickly. I'm going to be talking to you about a Spring Session. Spring Session is a framework for managing how surprising a session state in your application. So a few words about myself. I'm Oded Shopen. I'm a software architect working for Amdocs Israel, mainly working on microservices, event-driven, Kafka, all that stuff. And we also develop a lot of web applications for our customers. And that's how I got to be the Redis geek that I am today. You can follow me on the links that are available in the slides later. So why do we really need Spring Sessions? Just a very quick trip down memory lane in a way. We used to start with a single server back in the day. You had a servlet container, and it was good, and it managed the state as it was by itself. A user was able to log in. Let's call him David. Everyone say hello to David. He would like to log into the system. He would provide his credentials to probably a Tomcat server behind the scenes. And once that server was available, the server would create a session cookie, and that cookie would be passed to the user's browser. Now, whenever David would like to interact with the application, he would pass along this data, and the server would say, yeah, that's David. I know this guy. I know what he can do. I know his roles. And it worked pretty well. And of course, things scale, and your application is really successful. And now you need to scale your servers. So you might have like 3 servers in production. And then you'll add some load balancer layer on top of it. So you would be able to route the requests properly. So there was the idea of sticky sessions, where basically each one of the customers would be routed to a specific instance behind the scenes, and everyone will know exactly where to go. So that all worked well, as long as your servers were working properly and there were no problems. But of course, as you move to cloud environments and as you move to virtualization, the chances of losing a data or a server is highly likely. So when such a thing happened, and now David wants to find his session, the session is nowhere to be found. You can't find it on any of the other servers. And that really makes David a very sad customer, because you cannot use the web application like you wanted. So that's really where, and of course, as long as you move to microservices architecture, now your application is clustered among hundreds of servers, and they might be completely different code bases. Some of them might run different web servers. Some of them may be Jetty and things like that. So it's a very big problem. So the idea basically is kind of simple. Maybe it's a little bit of Captain Obvious, is to take the session data and move it away from the server and into an external database, right? And then all of your servers become fully stateless, and the actual data is stored in a database, which could be one of many, right? So to sum it up in a few sentences, so the idea is really to replace the basic HTTP session, which is built in to the servlet containers. You can do a drop-in replacement if you're using Spring Boot or some of these technologies. And it really makes your servers truly stateless, right? And that's really what you're trying to achieve here. Because if your server goes away, you can restart, and it would connect to the database and continue as if there's no problem. There's no need for sticky sessions. And it follows the cloud-native 12-factor principles, specifically principle number 6 that says that a 12-factor process must be stateless and share nothing, and any stateful data, like session state, must be externalized to a backend service, usually a database. OK, so that's great. So we have this solution. But why should we choose Redis? There are many options, as you can see in the documentation of the framework. So as anyone who's probably already knows, session state needs to be really fast, and Redis just happens to be an extremely fast database. It also, a session usually has the requirement to self-expire, right? So you want to create a session that maybe lasts 30 minutes. After 30 minutes of inactivity, you want to kick the user out of the bank application or whatever it may be. So self-expiring keys is a great solution for that. And with sharding and clustering, you can scale as your user base scales. So that was the why. I'll move to the how now. I'll do a very, very quick demo. There's a bit more complex demo available in this link that you can go to later. So what I have running here is Redis Labs, right? So this is all good. I have the Redis CLI here, which you can hopefully see. Let me try to make it a bit bigger. And I have a very simple application. The application is really just one class, right? It's a REST application. It exposes some endpoint orders. It returns some dummy data, less critical. And it exposes some login API that allows me to start my web session. Additionally, I have a security configuration, and the security configuration enables web security. Right? That's a simple standard boilerplate code to use session management. In my POM XML, which is my dependency management, I need to define dependencies on Spring Boot Starter Web, which is just a web application running Tomcat. And as I'm adding Spring Session, I immediately replace the built-in HTTP session with the session management provided by Spring. In addition to that, I need to provide some database, some implementation that Spring can find automatically at runtime. So once I'm provided here Spring Boot Starter Data Redis, it will automatically configure Redis to be the database that I will store my information in. So I can go here, and I'm going to try to log into my application. Right? And I'm getting a 302 redirect. Basically, you should log in first, right? So I will log in now with a username and password. And once I've done that, I'm getting 200 OK. Hopefully, you can see that. And I'm getting a session ID, right? And this session ID, if I move to Redis now, and I'll do a little bit of see the number of keys available. So I have a few entries here available. One of them is the key that I just created, which is right here, right? And I can see the keys that are available, the data that's available on this particular key, right? And I have a few attributes of this session that was already created. I can also take some data and see what I have, like, for example, the creation time. Okay, and it's a Java serialized object that represents the creation time of the database. So that's great. So now I have a key. I can take it, and now I can basically go to my orders API. And of course, I will be not allowed to use this API right now if I'm just trying to use it. But if I'll add as a cookie the actual cookie that was provided me in the login, now I'm getting the data back, and I can really use the application just passing the session ID all the time. So that's a very, very quick demo. Again, due to lack of time, you can see a more complex one using Spring Cloud and a lot of cool stuff in this link right here. All right, so a few production considerations. Some of them are going to be really captain obvious. I'm sorry, but sometimes it's good to remind it. So at a very minimum, if you're going to use Redis in production, always prepare to scale. At a minimum, use one master and two slaves with sentinels for failover. If you can, I would encourage you to use sharding, because then as your user base grows, you can grow the cluster very easily. And if you are using sharding, you should probably use the DNS proxy solution in case you're using the enterprise Redis Labs, because then your configuration would be a lot simpler. So as you can see here, without sharding, I need to provide all of the sentinels that are available in my cluster, a list of all the nodes. But if I'm using the proxy, all I need to do in my client-side configuration is just provide the proxy URL, and I can change the topology behind the scenes with zero changes to my configuration and my code. Number two is some pool settings. So this is using Redis connection factory behind the scenes, which is actually just a generic object pool of connections. And these are the default values that are provided if you just take the framework as is from start.spring.io. I would encourage you to change them for production. For the max active, you should consider to set them appropriately to the number of threads that you have in your Tomcat instances. The minimum idle is basically how many connections I'm going to keep forever, even if I don't have users using my application. So if you have like a sudden load in your application, it could take a little bit of time to create this initial connections. I would recommend to have a little bit of available connections always on standby. And of course, the max wait and max idle are configurations that you need to make sure are not using the defaults, because that you might just wait forever sometimes when you're trying to get a connection from this pool. You might want to set some timeout that is reasonable for your use case to prevent errors during connection when you're trying to get a connection. Number 3, if you probably need to do some metrics on your server and on your connection to Redis. So in Spring Boot, the way to do that is to use Spring Boot Actuator, which is a production-ready monitoring solution. It provides a lot of information that, as you can see here, like the heap size, the number of threads, the available memory, a lot of good stuff. Sadly, the connection pool to Redis, the Redis connection factory, is not exposed here, but you can easily add it because the Actuator is an extensible framework. So just by adding this dependency that is available in this link, it's an open source project, you can add all of the information about your connection factory to the Actuator endpoints. So number 4 is how you should monitor Redis. So again, if you're using Redis Labs, it's pretty easy. You have all the dashboards. If you're using cloud environments, usually they provide their metrics. If you're using on-prem, which is something that we happen to do a lot, you need to make sure that you're monitoring correctly and you monitor the process itself that's running, right? Because as you probably know, Redis is mostly a single-threaded database. And if you monitor the virtual machine and not the actual process, you might get incorrect metrics to your monitoring solution, like Grafana or something like that. So make sure you monitor the process itself. And number 5 is to monitor responsibly. That's a public service announcement. And again, kind of obvious to anyone using Redis that you should be careful with specific commands. Do not use keys star in a production environment, because that is going to be a blocking operation. It's going to run over all of your keys in the database. Like if you want to know how many sessions you have available. S members is going to return the data of a given set, right? So that set, maybe it's just a single user, but you can extend the framework to provide sets that basically contain all users of a given group. So that group might be very, very large, and then you go back to the key star problem, right? So a more safe solution would be to use a S-card to return the size of a given set, which is a cardinality of 1, or of course the info command that gives valuable information like ops per second. And I just want to hammer that point for a little bit longer. So this is a quick video of showing like endless logins to the system, all right? It's continuously logging in, and on the right-hand side, it's going to start a counter, and when the counter hits 0, I'm going to run the basically count keys command. Okay, so let's see how that goes. So it's running, you see logins happening all the time, 3, 2, 1, boom. Everyone saw that, right? No, you didn't, you're not Superman, so let's slow it down a bit. So now I'm running again at a slower pace, right? I'm just slowing down the video, it's still the same speed. So now it's 3, 2, 1. Oh my God, my application is unresponsive, no one can log in, okay? So make sure you're not using commands like keys and things like that that could really impact your performance. And the last item I want to talk about is a little bit of going inside the framework itself and see the source code itself. Because we noticed something quite interesting when we did our performance testing, right? What happens when your application is completely idle and no one is using it, right? You would expect to see pretty much a flat line in Redis monitoring. But what we're seeing is this interesting like spikes, right? You see these spikes here? It's like every minute, exactly at the 0, mark, you get this spike. Now this is not a big deal. It's like 10 operations per second, not a big deal. But what if we start to log into the system? When we create a lot of logins to create a lot of sessions in some performance testing. So you would expect some linear increase in the graph. But again, what you see is these spikes again. You see that? That's like every minute, you're going to get a sudden spike of like 4 times the regular runtime. And started looking into it a bit deeper and trying to understand really what is the reason behind these spikes here, because this could represent a very big problem if you're going like this to production. So if you go into the source code, and again, it's a fully open source project, like any Spring framework, what you'll notice is that there is a specific cron job running every minute by default. And that's something that's coming out of the box. Okay, and you can override this if you'd like. Luckily, in the latest versions. In previous versions, it was just hard-coded, every 1 minute do it. And what this basically does is clean up expired sessions. Right? It would loop over all the expired keys, and it would delete them, and then do a little bit of like a touch command, like to get the data to make sure it's deleted from Redis. Right? So every minute on the minute, every instance in your cluster would go to the database, and we'd run this expiration command. Now you want to wonder, why do I even need to do such a thing? I mean, Redis has self-expiring keys. I don't need to monitor this on the client side. Redis can do it for me. And the main reason for that is that Spring Session implements the HTTP session framework. And one of the things that you expose in this API is the ability to provide session deleted event and a session expired event back to the client to allow some cleanup if you want to clean like WebSockets, if you want to notify a single sign-on server that that someone is logging out, right? But in order to do that, you have to have the session available. So they really couldn't just let Redis delete the session from the database, because then you wouldn't have a chance to do this cleanup activity. All right, so the way they solve it is, as you can see here, when you have a specific session in Redis, you have actually 2 keys for each session. Right? One of them is the actual session itself with all of the available keys. And there's another session with the expires key, okay, the expires command. And that is the one that will expire after the default 30 minutes if you don't change it. Right? So the actual expire key, which actually holds nothing, would expire after 30 minutes and would just notify your database. And then you'll have 5 minutes more to make sure that you clean up your session before it will actually delete the real session from the database. Okay, so you have this 5-minute interval where you can handle expirations. So again, Redis guarantees expired keys, but it doesn't give you a guarantee of when it will do it when it's doing it in a passive way, and that's why they had to implement this mechanism that guarantees the expiration within this specific 5-minute window. But of course, there is a risk here, as you can probably guess. We saw these spikes, right? I mean, if you go back to this slide from the beginning, it's very clean and very nice, but it's not really how it looks, right? It looks more like this. This is what you actually have in your production environment, right? Every single instance in every single server will go to the database at the exact same second, and it would trigger to clean up these sessions all at the same time, right? So to recap, every minute each server will try to delete the keys. A lot of redundant calls if you have multiple servers, because only one of them is actually going to successfully delete this key. All the rest will just waste their time. Then Redis would notify each instance about the session expired event. Okay, there's a pub/sub mechanism going on there. So every instance will get the notification, and will go back to Redis to try to get the session data. Okay, so there's like 3 hops here that you might not even need. And that's why you got these spikes, like every X number of, every minute exactly, you got this spike. I remember we were doing some performance testing, and we started a test. We simulated the huge load test. It was like, we started like a few, about 5,000 users, and the testing guy said, I messed something up, I need to close the test. So he stopped the test, logged out all the users, and I'm sitting there with the dashboard, and I see this spike to like 200,000 keys per second once he stopped the test, right? Because all of these users log out in the same second, and every instance has to really perform this issue. So if you have like 100 servers in production, and you happen to expire a very simple value like 2,500 keys, that will be like 500,000 accesses at the same second to your production environment. And if you add more servers, you're just going to get a bigger problem here. So be very careful of this. So how are you going to solve such a thing? Well, if you don't really care about these expiration events, you can just change this cron job parameter. As you saw, it was externalized parameter. You can change it to some imaginary impossible date, like February 31st, and then you will never really get this point where it will clean up those sessions for you. You can also disable the registration for the session deleted and session expired event. It's a configuration in Spring session itself. Just a few lines of code of bean annotation, basically telling to Redis, don't send me any events for session expirations. You will have to do this in every single server that you have. Even if one of the instances is going to register these events, all of them are going to get it again. So again, so it's not a perfect solution. Another option you can do is just basically disable the implementation. Because it's open source, you can override it, right? So you can disable the implementation of the Redis message listener container. That's the container that really handles the session expirations. And you might create just a single instance or a couple of instances to handle the expirations if you have anything specific that you want to do. So very important to know, to be aware of that. So quick recap, be prepared to scale even if you think you have a small user base in the beginning. As you can see, you can hit very high numbers very, very early. Monitor well, monitor with caution, and as we all know here, open source rocks, so you should get involved, look at the source code, make sure that you are familiar with the frameworks, and if you need it, just tweak the framework to your own use case. So that's it for me. Thank you very much, and have a great day.
Thank you very much, Oded Shopen.